Did you know that some scientists think Jupiter used to be twice as far away as it is today? The thing is, no one can agree if this is true or not. But what we do know is that if this were true, then it would mean that Jupiter has had a profound effect on our solar system, perhaps even more than any other planet. It may have destroyed another planet, meaning that there could have been many more planets than there are now. In fact, it could have been up to 50% more. We think Jupiter is around 300 times heavier than Earth, so it's absolutely massive. And it's also thought that it formed about 10 times faster than Earth. So while Earth was gathering up its mass over millions of years, Jupiter was gathering up its mass in just tens of thousands. This means that when Jupiter was young, it was incredibly dense. And as it grew in size, its gravity must have been absolutely insane. So let's say Jupiter was around twice as far away from the Sun as it is now. What would have happened to the smaller rocky planets like Earth? Well, anything that got too close to Jupiter would have been pulled in by its immense gravity and either destroyed or flung out of the solar system entirely. This would have left gaps in the asteroid belt and the Kuiper belt, as well as making the inner solar system more chaotic and less hospitable to life. This means that Jupiter may have played a major role in setting the stage for life on Earth, but in a very roundabout way. It could have cleared the solar system of all the small rogue planets and made room for Earth to be the only planet with liquid water. We don't know if this actually happened, but it's definitely possible. In fact, it is not crazy to think that Jupiter was once much further away because there is evidence that suggests it was. For example, the asteroid belt between Mars and Jupiter is weirdly empty. If you've ever watched one of our videos before, you'll know that we're big fans of weird gaps in space. There's something really satisfying about them, and this one is one of the biggest. The asteroid belt should be full of asteroids, but they're mostly absent except for the region between Mars and Jupiter. That's because Jupiter's gravity prevents anything from getting too close to it. But it should also be full of small bodies that were never able to coalesce into planets. These are called planetesimals. They're kind of like the building blocks of planets. And without them, planets can't form. But Jupiter's gravity is so strong that it prevented these planetesimals from coming together and forming planets. But this shouldn't have always been the case. When the solar system was young, Jupiter was probably much further away and smaller than it is now. And back then, the asteroid belt was full of stuff. Jupiter's gravity would have ripped apart any planets that got too close and flung them out of the solar system or further into the asteroid belt. And where did those destroyed planets go? Well, some may have ended up in the Kuiper belt or the Oort cloud, which are both regions of space beyond Neptune that are also full of icy bodies. In fact, it is thought that most of the Kuiper belt and Oort cloud objects were once part of the asteroid belt, but Jupiter's gravity pushed them out. But that's not all. Jupiter's gravity would have also created a disk of debris around the Sun, and as that debris cooled, it would have formed a thin layer of ice. And as more and more ice built up, eventually it would have become so heavy that it collapsed under its own gravity and formed a planet. Scientists call this planet the Great Attractor. Now, we haven't actually discovered this planet yet, but we have found some clues that suggest it may exist. For example, there seems to be a gap in the distribution of comets that could mean that something is hiding in our solar system. And that something could be the Great Attractor. It would explain why there are so few comets coming from certain parts of the solar system, and why the orbits of some comets are so strange. But the thing is, we still don't know if this planet actually exists. And we still don't know if it was formed from material that was originally in the asteroid belt or if it was captured by Jupiter's gravity. So while it's fun to speculate, we just don't know enough to say for sure. But here's the thing, whether or not the Great Attractor exists, it doesn't really matter because Jupiter has still shaped our solar system in a big way, And that's all thanks to its gravity. You see, gravity is more than just a force that pulls us down to Earth. It's also what holds the solar system together. As the largest planet in the solar system, Jupiter's gravity has a huge influence on the other planets and everything else in the solar system. And we can see this influence most clearly in the asteroid belt. You've already learned how Jupiter's gravity affects the asteroid belt, but it also affects the orbits of comets and other small bodies in the solar system. In fact, some scientists think that Jupiter may have even captured the asteroid Hygeia and made it a Trojan. Trojans are asteroids that share an orbit with a planet, but they stay far enough away that they're not captured by the planet's gravity. Instead, they're locked in a gravitational dance with the planet, moving around it in a stable orbit. Some scientists think that Hygeia is actually a Trojan of Jupiter, but it's hard to say for sure. Hygeia is the 12th largest asteroid in the solar system, and it's more than twice as wide as Earth's moon. If it was captured by Jupiter's gravity, it would be the largest Trojan in the solar system. But if it's not captured, then why does it orbit the Sun in exactly the same path as Jupiter? Well, we still don't know. But it's possible that Jupiter's gravity nudged Hygeia into its current orbit billions of years ago. But that's just one example of how Jupiter's gravity has affected our solar system. It's also thought that Jupiter's gravity is responsible for the unusual tilt of Uranus and Neptune. Both planets are tilted on their axes by more than 90 degrees, which is strange because most planets in the solar system are only tilted by a few degrees. This means that Uranus and Neptune rotate almost perfectly on their sides. And scientists think that Jupiter is responsible for this because it's the only planet massive enough to have affected them. As the solar system formed, Uranus and Neptune were probably orbiting the Sun in nice circular paths. But then Jupiter came along and its gravity knocked them out of their orbits, putting them into their unusual tilted orbits. But again, this is just a theory. We don't know for sure why Uranus and Neptune are tilted like that. But if that's not enough, there's one more thing. Jupiter's gravity is also thought to be responsible for the strange rings of Saturn. Saturn is the only planet in the solar system with large complex rings, and scientists think that Jupiter is the reason why. When Saturn was young, its rings were probably much simpler than they are now. But then Jupiter passed by and its gravity ripped apart some of Saturn's moons. The debris from these moons formed the rings that we see today. But again, this is just a theory. We don't know for sure why Saturn has rings. But regardless of whether or not any of these theories are true, it's clear that Jupiter has had a huge impact on our solar system. It's the sculptor of the solar system, and it's given us the world as we know it today. But there's a lot more to Jupiter than just its gravity. In fact, Jupiter is one of the most interesting and mysterious planets in the solar system, and there is still so much that we do and know about it. For example, Jupiter has more than a dozen known moons and dozens of known rings. We've only explored a small fraction of these moons and rings, and there is still so much that we do and know about them. Jupiter also has a giant red spot, which is a massive storm that's been raging on the planet for centuries. We still do and know exactly what causes the red spot or how long it has actually been raging for, and that's just scratching the surface. There's so much more to learn about Jupiter and the other planets in our solar system, and that's why we love space so much. There's always something new to discover, and every discovery brings us one step closer to understanding the universe around us. But we can't do it alone. We need your help. Please subscribe and support us.